Good evening everyone. My name is Manpreet. Today let us discuss topic about nucleophilic substitution reaction. That is nucleophilic substitution reaction. Now nucleophilic stands from nucleophile and substitution means substitution of one atom or group of atom takes place by another atom or group of atom. Let us take an example of alkyl halides. In alkyl halide, R stands for any alkyl group and X stands for any halide or halidine, you can say, or halogen atom. As we know, so you can take it as, write it as carbon CX. As we know, electronegativity of carbon is less than as compared to electronegativity of halogen atom. So that's why carbon acquires partial positive charge and halogen carries partial negative charge. So that's why halogens are, you can say, polar in nature. Halogens are polar in nature, and due to its polarity, these are highly reactive. These are highly reactive in nature. So these alkyl halides show nucleophilic substitution reaction. As we know, when, so you can say, as we discussed that alkyl halides show nucleophilic substitution reaction. It means in case of alkyl halides, carbon has partial positive charge, so that's why nucleophile can attack easily on the partial positive charge carrying carbon atom, and after that replacement of halogen atom can be takes place by the nucleophile or any incoming nucleophile like, you can say, OH negative, OR negative. First of all, discuss what is nucleophile. Nucleophile is electron rich species, nucleus loving species, and have tendency to donate at least one lone pair of electron. Now nucleophile can be negatively charged species, for example OH negative, OR negative, Cn negative, etc., or can be neutral species, for example water molecule, ammonia, primary amine, secondary amine, or you can say tertiary amine. Because in case of water has two lone pair of electron, in ammonia has one lone pair of electron. Similarly, in case of primary amine, secondary amine, and tertiary also have one lone pair of electron which can easily donate. So we have discussed about the topic, that is nucleophilic substitution reaction. Now, in this case, when alkyl halides, when alkyl halide react with any nucleophile, let us suppose take an example of hydroxide ion. In that case, now in case of alkyl halide, carbon has partial positive charge and halogen has partial negative charge due to its more electronegativity. So that's why due to partial positive nature of carbon atom of alkyl halide, incoming nucleophile can easily attack, and as a result of which halogen removes from here by taking its bonding pair of electrons. So this is nucleophilic substitution reaction. That means nucleophile will come attack on the alkyl halide, that means on the carbon of the alkyl halide, and after that replacement of halogen will be takes place by incoming nucleophile. That's why these reactions are known as nucleophilic substitution reaction. Now let us discuss, there are two types of nucleophilic substitution reaction. First one is, there are two types of nucleophilic substitution reactions. One is bimolecular nucleophilic substitution reaction. It is represented as SN2. So we call it as bimolecular nucleophilic substitution reaction. And second one is your unimolecular nucleophilic substitution reaction. It is represented as SN1. That is unimolecular. One stands for unimolecular nucleophilic substitution reaction. Now, in case of bimolecular nucleophilic substitution reaction, what will happen? That is, nucleophilic substitution reaction can take place in a different manner, and in case of bimolecular nucleophilic substitution reaction, this reaction takes place in a different method. That is, in case of, let us first discuss about bimolecular nucleophilic substitution reaction. Now, let us take an example of methyl bromide, CH3Br, will react with hydroxide ion. What will happen then? This is your methyl bromide. This is your reacting species. This is your, what is your reacting species, and this is your incoming nucleophile, that is your attacking species. This is your attacking species, or you can say your nucleophile. Okay, now what will happen when methyl bromide react with hydroxide ion? What will happen? Bromine of methyl bromide is replaced by hydroxide ion. Got it? And bromide ion will be removed. Okay, this is your bromide ion, and what will be formed? Your methanol will be formed as a final product. Now, in case of bimolecular nucleophilic substitution reaction, the rate of reaction, that means rate of reaction depends upon the concentration of both reacting species, reactant, as well as the hydroxide ion, that is your incoming nucleophile. That's why this reaction is known as bimolecular nucleophilic substitution reaction, because rate of reaction depends upon the concentration of both the reactant as well as the hydroxide ion. So the rate of reaction follows second order kinetics. So follows second order kinetics. Rate of reaction, that is rate of reaction, may be expressed as K is your rate constant, your methyl bromide, which is one of the reacting species, and your hydroxide ion, which is your incoming nucleophile. So bimolecular nucleophilic substitution reaction is a follows second order kinetics. Understood that? Now this reaction takes place through only one step. Takes place through single step. Step, or you can say this is one or single step reaction. Now discuss the mechanism of SN2 reactions. As we know that in this reaction, two reacting species, that is concentration, we will take the concentration of methyl bromide as well as the hydroxide ion. Now let us discuss about the mechanism of SN2 reaction. This is your hydroxide ion, that is your incoming nucleophile or your attacking species, and second one is your methyl bromide. This is your methyl bromide. Okay. Dash line represent that hydrogen atom is present below the plane, but this represents wedge line represents that hydrogen present above the plane. Okay. Now what will happen? This incoming nucleophile attacks from backside of the bromide ion. Now the question arises, why nucleophile attacks from backside? The reason behind is that bromine is electronegative in nature. It has also negative charge, and the incoming nucleophile also has negative charge. So that's why, due to negative repulsion, it will not attack from bromine side. It will attack from backside of bromide ion. Okay. Now what will happen? The bond between hydroxide ion will be formed, and bond breaking between carbon and bromine will start. This is your transition state. Okay. What will happen? Hydroxide ion, that is your incoming nucleophile, attack from backside to the carbon of methyl bromide. The bond between hydroxide ion and carbon will start form, and bond breaking will start between carbon and bromine of methyl bromide. Okay, ultimately what will happen, bromine will remove with its bonding pair of electrons, and so that's why, and complete bond will be formed between carbon and, so finally alcohol product will be formed, that is bond between carbon and incoming nucleophile will be formed, and bromine will be removed out along with its bonding pair of electrons. So that's why this is your single step reaction taking place through taking place through the formation of transition state. Now let us discuss about the reactivity order. Reactivity order of alkyl halides towards SN2 reaction. Methyl bromide is most reactive as compared to primary bromide, or you can say alkyl halide. Simple methyl bromide is more reactive as compared to primary bromide, which is more reactive as compared to secondary which is more reactive as compared to tertiary bromide, or you can say simply simple alkyl halide is more reactive as compared to primary halide, then secondary, and after that tertiary halide. Now why it is so? In case of methyl bromide, there is only 3 hydrogen atom, but in case of primary there is a 1 methyl group. In case of secondary there is 2 methyl group, and in case of tertiary there is 3 methyl group. That is your tertiary butyl bromide. Okay, why it is so? Now in case of simple, that is we call methyl bromide, there is only hydrogen atom, so there is least steric hindrance. Interference of bulky group is known as steric hindrance. There is no bulky group, there is only 1 bulky group, there is 2 bulky group, there is 3 bulky group. So that's why attack of incoming nucleophile will be easiest in case of methyl bromide as compared to tertiary butyl bromide. So that's why reactivity of methyl bromide is greater than as compared to tertiary butyl bromide, or you can say tertiary halides. Okay, this is all about. Now let us second discuss about unimolecular nucleophilic substitution reaction. Call it represented it as SN1 reaction. Let us take the example of tertiary butyl bromide. When react with halidine, that is your incoming nucleophile, what will happen? Your tertiary butyl alcohol will be formed as final product. Okay, now in this case what will happen? Rate of reaction depends only on the concentration of one reactant, that is your tertiary butyl bromide. So that's why this reaction is known as unimolecular nucleophilic substitution reaction. And rate of reaction may be represented it as your case here rate constant, and depend only upon the concentration of tertiary butyl bromide, that is CH3 thrice CBr. So follow first order kinetics. Okay, now in this case what will happen? Discuss its mechanism of SN1 reaction. Now let us discuss mechanism of SN1 reactions. In the very first step, what will happen? The bond between carbon and bromine, carbon of tertiary butyl bromide and bromine, will cleave. So ultimately the formation of carbocation will be takes place. Okay, as we know bromine is more electronegative, so that's why it will take all the bond pair of electron towards itself and will be removed, and ultimately the formation of carbocation will be takes place. Okay, this is your slow step. As we know, as we have already studied that in case of in chapter chemical kinetics, that slow step is rate determining step. Okay, so in the second step, carbocation is highly reactive species because it is unstable, because octet is not complete, so that's why it is easily attacked by incoming nucleophile. What will be formed? Tertiary butyl alcohol will be formed as final product. So in the first step, which is your rate determining step, and in the rate determining step there is the rate of reaction depend upon only on the concentration of depend upon the concentration of only tertiary butyl bromide. So that's why this reaction is known as unimolecular nucleophilic substitution reactions. Okay, this is all about SN1 and SN2 reactions. Now let us discuss about the reactivity order of alkyl halides towards SN1 reaction. As let us take an example of methyl bromide. Then your primary, and then secondary, and after that tertiary butyl bromide. Okay, now out of simple methyl bromide, or you can say simple alkyl halide or methyl bromide, or then your primary bromide and secondary. This is your primary halide, you can say, and your secondary, and then your tertiary halide. This is your simple alkyl halide, that is methyl bromide or simple halide, out of which tertiary carbocation is more stable. As we know that tertiary carbocation is more stable than secondary, then primary, and then simple methyl carbocation. Okay, so that's why reactivity will be greater in case of tertiary halide, then secondary, then primary, then simple alkyl halide, that is your methyl bromide. Okay, this is all about nucleophilic substitution reactions and its types, that is biomolecular nucleophilic substitution reaction and unimolecular nucleophilic substitution reaction. Thank you.